So this is part 2 of experiment 20, which deals with magnetic fields and induced EMF. So you're going to, on the computer, you're going to once again open induced 2. If I can find this guy, there we are. Okay. And then for this part, the idea is that last time we were only looking at one peak. This time we're going to actually graph out doing 10 revolutions. So everything is set up the same as it was last time. But this time, when you're spinning this guy over here, you want to make sure that he's going fast enough so that when you let go, he'll spin 10 times on his own without you needing to touch him. And then, so on the graph, I'm just going to go ahead and do that. Just going to hit start. I'm going to get this spinning. You can see every time that it peaks is another time that it's made a revolution, and we're just letting this guy come to a stop.
Is that too much?
Okay, and then you're going to just take the last 10 peaks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all these ones. And then you need to get a couple of values off of this. So the first thing you need to get is change in time for each of them. So the way you do that is go up to this button over here that has the Smart tool, and that'll give you some crosshairs. You take these crosshairs and put them at the top of one peak, and then move it, move it across, and then that 0.72 that I'm looking at right there, that gives me how far the distance is between these two peaks, and because time is on the x-axis, that is our time between each revolution. And then you do that for all 10 of these, find out what delta t is there. And then you want to get new crosshair for down here. Got this guy. And then I need 1, 2, 3, 4, 5, 6, 7, 8, 9. The last 10 of these guys. And now you need to get the height of them. So put your crosshairs on the top and drag downwards, and then this number that you see in the center, that is height, which is equivalent to voltage. And when you do your graph, you're going to make a graph that shows the, that's the wrong. You're going to do a graph that shows the slope of the velocity in meters per second compared to the voltage, which is in this case like your EMF, electromotive force. And the electromotive force is what you got off of the height difference, and then velocity is you take the time that you got from between peaks, and then you plug it into, where is this equation?
Velocity? This is velocity.
There we are. Couldn't find it on the board. You plug it into this equation right here, and then, what is our R?
Our R was 2,000 turns, I believe.
So R should just be 2,000 revolutions divided by delta t, 2 pi r, divided by what you found for the distance between these. And that's it.